Now here for example 27, it says that we need to solve the inequality. So let's look at what's the setup for this inequality. Notice that in this inequality, we have a y variable on the left side and a y variable on the right side from the inequality sign. So if we wish to solve the inequality, what we have to do is put all the y's on one side and all the numbers on the other, which we're going to call the isolation of y. So that is our strategy here. We got to put all the y's on one side and all the numbers on the other. All right, so let's try to do that here. One thing that I can see is that we can subtract 1.8 to both sides of the inequality. If we do that, notice that 1.8 will cancel out. So now we can bring this expression here. So we're going to have negative 0.4 y. We can bring down the inequality. Let me write that better here. We can bring down the inequality. We can combine the numbers here. 2.2 minus 1.8, that gives us 0.4. Now we can bring down the negative 2y. All right, so this is our new expression. And like I said, we've got to put all the y's on one side. So one thing that I see here is that we can add y's, two y's to both sides. This way, the two y's will cancel out on the right side. And now, if we combine negative 0.4y plus 2y, that gives us 1.6y. We can bring down the inequality, and we can bring down the 0.4. Okay, so notice what we have now. Now, we have all the y's on one side and all the numbers on the other. But in order for us to solve, we got to leave this y by itself. So our last step here is to eliminate 1.6. And to do that, we're going to divide 1.6 to both sides. Because notice that the 1.6 is multiplying. If you wish to cancel it, you got to divide. So we do that. And now, if you do 0.4, this is just a number. So let's find out what that is. 0.4 divided by 1.6. That's going to give us a total of 0.25. All right, let me write that better. 0.25. And notice that we have solved for y now. Y is less than 0.25. Now, let's move on to example 28 here. Now, example 28 is the following. It says Jacob is working on his math homework. He decides that the sum of the expression 1/3 plus 6 square root of 5 over 7 must be a rational number. Okay? Must be a rational number because it is a fraction. Is Jacob correct? Tell me why. Well, let's see. Now, in order for us to see what's going on here, we need to understand the definition of a rational and irrational number. But the best way to do here is to actually see what those numbers represent. So the point of this example is, if we add these two fractions, are you going to get an irrational number? Okay. Well, let's see what happens here. Let's see what this gives us here. Let's see. 1 divided by 3. If we wish to write 1 divided by 3, let's see what that gives in the calculator. 1 divided by 3. Notice that this is equal to 0.333, and the 3 keeps repeating, so I'm going to put the little hat on top. Now, this is a rational number. This is a rational number here. Why is it a rational number? Well, this is a rational number because the decimals repeat. Okay, what do I mean by the decimals repeating? Well, notice that if you put in the calculator, you get 0.3333333. So notice after this 3, most likely, just by looking at the pattern here, you're going to continue with that with 0.33333. Because the decimals, they do repeat, or they follow a pattern, which is pretty much, it's always going to be a 3, then this is a rational number. Now, let's see what happens with 6. square root of 5 divided by 7. Let's see what that gives us in the calculator here. 6. Well, let me put the whole numerator in a parenthesis. So we're going to have 6 square root of 5, close parenthesis. Let me close it. Now that's the whole numerator divided by 7. If you do this, you will notice that we're going to get 1.916629.695. Now, when you put in the calculator, if the decimal repeats, then yes, that's a rational number. But let's look at how the decimals behave here. There's no clear pattern. It's not like all the numbers repeat. And because we have this example here, then this is an example. This is an irrational number. Why? Well, because the decimals don't follow a pattern. So notice that when it comes to 1/3, we have an example. This is an example of a rational number because the decimals do repeat. And 6 square root of 5 divided by 7. This is an example of an irrational number because the decimals do not repeat. So if we look at the initial problem, it says if we add those two, 1/3 and 6 square root of 5 divided by 7, are we going to have an irrational number? Well, we know that 1/3. So this is what we want to find out. Is 1/3 plus 6 square root of 5, that's an ugly 5 here, 6 square root of 5 over 7. Is this going to be a rational number? Well, we know that this number is rational. And we know that this number is irrational. And there's a rule in mathematics that says a rational number plus an irrational number is irrational. So if we look at our example, we know that this is rational, and we know that this is irrational. And because this rule in mathematics that says if you add a rational with an irrational number, then the product is irrational. What I mean by product, I mean addition. So let's come back to the question. Is Jacob correct? Jacob said that this was a rational number. So no, Jacob is incorrect. So Jacob is wrong. Because I'm not going to write the whole sentence, but because of this. Because a rational number plus an irrational number is irrational. So Jacob is wrong because a rational number plus an irrational number is irrational. And we saw that 1/3 is rational. And we saw that 6 square root of 5 over 7 is irrational. So yes, Jacob is wrong. Now, if we observe example 29 next here. So let's see what 29 is talking about. Let me make the grid a little bit smaller here. Okay, so what do we have here? Well, let me actually make it bigger. Okay, cool. Put you on the side. Perfect. All right, it says graph the inequality, okay, on the set of x's below and state the coordinates of a point in its solution. Okay, Perfect. So let's see here. Now, what we wish to do is we're going to get this inequality and we're going to graph it. Okay, so let's rewrite this. So we have y less than 2x minus 5. This is the inequality that we wish to graph. When we're solving for, when we're graphing, I'm sorry, when we're graphing inequalities, you can think about this as if it was some kind of a equation. We can graph this line, y equals 2x minus 5. Okay, so if what we can do here, we can just get our calculator and we can put 2x minus 5. So let's graph the equation. Now, if I press second table, you will see that this is the table of values. We got many points here. Let me just choose some points. So I know that I have a point at 0, -5. So that's 0, 1, 2, 3, 4, 5. There's a point. Let me get another point. 1, comma, -3. So when x is 1, comma is -3. 1, 2, 3. Let me just get another point. 2, comma, -1. So 1, 2, comma, -1. Perfect. So we can see that we're going to have a line here. But when it comes to inequality, there's always two kind of lines. Either a solid or a dotted line. In this case, our line, so our line here is dotted because there is no equality and the inequality. So if we look at our symbol here, this is just saying greater than. Because it says greater than, then we know that we're going to have a dotted line. Because it just says that it's greater than, then we have a dotted line. Now, how do we know we wouldn't have a solid line? Well, if the inequality, if we change the problem to greater or equal to, if there's an equal sign underneath it, or just a little line underneath it, then in that case, we would have a solid line instead of a dotted line. But because we don't have that, then this is a dotted line. Now, we have the line, we know it's dotted, and when it comes to inequalities here, we always need to have some kind of a shade. So the question is, do we shade the left side or do we shade the right side of the line? Well, everything has to do with what is the inequality talking about the y values? Here it says, I want all those y's which are greater. So if we look at our graph here, notice that all those y values, so this is the y-axis, so all the y values, you're going to find them up and down. Notice that in the left side of this line, all the y values are going to be greater. So that means that we're going to be shading the left side. Well, except here, be careful here. You don't want to pass that line. So all we're going to do is just, well, I'm going to be shading the left side. Why? Because I want all those values which are greater, and the greater y values are located on the left side. So if we look at here, it says graph the inequality, which we already did. Now, the next thing that we want to do is we want to state the coordinates of a point in its solution. Now, what do they mean by that? It means that whatever point you choose on this shaded region, that is going to be a solution. So this inequality has many solutions. If I pick this point, that's a solution. If I pick this point, that's a solution as well. If I pick this point, that's a solution. If I pick this point, that's not a solution because it's not on the shaded section here. So out of the many points that you can choose, if we want to state a coordinate of a point, we'll just choose a point that is on the shaded region. I'm just going to choose the easiest one, which is the origin, 0, 0. So a point in the solution, well, I'm going to call it a solution point. is, well, I just chose the easiest of them all, 0, 0. Okay, I mean, you could have choose any other point. You could have chose this point as well, or you could have chose this point as well. The whole idea here is that you just got to choose a point that is part of the shaded region here. So that takes care of example 29 now. Now, let's look at example 30. In example 30, we can see the following. It says, Sandy programmed a website's checkout process with an equation to calculate the amount customers will be charged when they download a song or songs. The website offers a discount if one song is bought at the full price of $129, then each additional song is $0.99. Listed the equation represents the cost when S are the songs that are downloaded. Okay. So let's try to come up with an equation here. Now you can think about this as if it was some kind of an arithmetic sequence. Now, how do we know it's an arithmetic sequence? Well, let's put a scenario. Let's say that you buy a song. So that's, you buy your first song, well, you pay $129. Let's say that you buy two songs now. So it's going to be $129 plus the $0.99. That it's the price of any additional song. So now what we're going to have here is the following number. Well, we're going to have, let me erase this, 1.29 plus 0.99. So notice that your cost now is going to be 2.28. So now this is when you have two songs. So you want to buy another song. Well, you got to add another 0.99. So if we do that, plus 0.99. Now your cost is going to be 3.27. Well, you want to buy another song. Well, you got to add another 0.99. And if we do this correctly, this is going to give us 426. And if we want to buy another song, well, you already saw a pattern. So this is an example of an arithmetic sequence. Where the first term, or A1, is 1.29, and the common difference is 0.99. So why are we even bothered to identify as an arithmetic sequence? Well, because if we want to state an equation, then we can use the arithmetic sequence, because we know that all arithmetic sequence, they always look like AN. Okay, we look like AN equals A1 plus N minus 1 times the common difference. But notice that we already have those values. So instead of calling it AN, we're going to call that the cost. We're going to call it the cost C of S. And A1 is 1.29 plus, instead of N, we're talking about songs. So it's going to be S minus 1 times the common difference, which is just going to be 0.99. So this is an equation that we can use that it will represent the cost. All right, so we have built an equation here. And let's see, what are they asking us to do with such an equation? Well, it says Sandy figure she will be charged $52.77 for 52 songs. Is this the correct amount? Let's justify our answer. Well, let's see. We have a function that can give us the cost. Now, here is saying, well, what is going to happen when I buy 52 songs? But we know that in our equation, S, this is equal to songs. And that's supposed to be an S. So S is equal to songs. We have an equation. Let's plug that in. Let's see what happens. What is the cost after 52 songs? So we're going to have S parentheses. And instead of S, we're going to put in 52. Close it. let's see, 1.29 plus, and again, we're looking for 52 songs, so we're going to plug in 52 for S. That's what I'm putting in red, so you can see the difference, minus 1, times 0.99. All right, so let's see what that happens. So it means that the cost of 52 songs is equal to, well, let's see what this is. So 1.29 plus parenthesis 52 minus 1. I'm just going to plug in 51 times 0.99. So this means that the cost after 52 songs is 51.78. So Sandy said that she will be charged 52.77. So is she correct? No, she's not. Nope, Sandy is not correct. Now it says that we need to justify our answer. So we can say, well, we use our function to justify the price. Or we can just say according to our equation, she will be charged $51. Well, let me put the dollar sign there because we're talking about cost. So 51.78. So no, she's not correct. Is this it? For example, 30, let me check. Yep. So we got an equation and we use that equation to justify the cost after 52 songs. All right, so let's see. Question 31 now. If we look at question 39, it says, a family is traveling from their home to a vacation resort hotel. Okay. The table below shows the distance from home as a function of time. Cool. Determine the average rate. Determine the average rate of change. Well, determine the average rate of change between hours 2 and hours 7. Okay, so when we talk about average rate of change, think of slope. We can use the slope function or the slope equation to calculate the average rate of change. And if you remember, when it comes to slope, the slope is equal to, which they use the letter m, so let's use that. The slope you can define as m equals to y of 2 minus y of 1 over x of 2 minus x of 1. Okay, so when you've been asked to find the average rate of change, if you see this word average rate of change, you need to start thinking, well, I need to find the slope, because slope will always give you the average rate of change. Now, if you notice here, it says, well, we need to find the average rate of change between hour 2 and hour 7. So we can get the coordinate points that are needed for our slope function from the table. So we need, again, if you want to find the slope, you need 2 points. So our first point is going to be what happens when the hour is 2. So when the hour is 2, the distance is 140. So we can think about this as a coordinate point, 2 comma 140. And again, we did say that we need 2 points. So the second point, we see that we also want to find the average between 2 and 7. So our second point is what happens at 7. So we're going to have 7 comma 480. We have 2 points. We have the slope formula. Let's find the slope. So average rate of change okay, So the average rate of change, we said that we was the slope, which is going to be y2, which, I mean, from our formula, let's call this x1, let's call this y1, let's call this x2, and let's call this y2. So all we got to do is just literally just plug that in. So we're going to get 480. So y2, which is 480, minus y1, which is 140, over x2, which is 7, minus x1, which is 2. So this is equal to, if you do this in the calculator, 480 minus 140, that is equal to 340. And 7 minus 2, that is equal to 5. So this is equal to 340 divided by 5. If you do that in the calculator, you will see that is equal to 68. All right, so this is just a number, but we also want to know the units. So let's see. In here, our units will be miles per hour. Now, how can we determine that? Well, notice that the distance, it's given in miles, and notice that the time is being given in hours. So the rate of change in here will be miles per hours. I don't know why the pen is doing this. So miles per hour. Don't forget to include the units in your answer. So this is miles per hour. And this is miles per hour. So in here, our rate of change is 68 miles per hour. The rate of change between 2 hours and 7 hours. All right, so here it is, example 32. Now here in example 32, they're saying Nora says that the graph of a circle is a function because she can trace the whole graph without picking up her pencil. Okay. Mia is saying that the circle graph is not a function because multiple values of x map the same y values. Okay, well, that's interesting. Now, our job is to determine if either one is correct, and we need to justify our answers completely. Okay, so let's see here. Now, what exactly are they trying to look in here? It says Nora says that the graph of a circle is a function. So they're having a discussion about a graph of a circle. Well, let's graph our circle. So this is a line. Let me make a perfect circle using this tool here. So if we're going to have a circle, this is the circle that they're saying. Okay, so we have our circle. Let's see what they're saying is true. It says, Nora says that the graph of a circle is a function because she can trace the whole graph without picking up her pencil. Well, that is true. You can literally just go around the circle. So let me move the circle here. And Maya is saying that, well, nah, it's not a function because multiple values of x map the same y values. Well, we have one test that can determine if it's a function or not, and that is called the vertical line test. What this is saying, if you decide to use the vertical line test to determine if it's a function or not, so we have, this is circle. We know that this is how the circle works. The vertical line test, it says that if you draw a vertical line, and if that line touches more than once, then this is not a function. But notice that it doesn't matter where we draw this line on the circle. You're always going to be touching more than one point. So here you touch it here or here. It doesn't matter where you graph this line. You're always going to be touching more than one point. So if we use the vertical line test, the circle is not a function. So in here, the circle is not a function. Well, why? Because of the vertical line test. So at least we have come up with our own conclusion, and that is that, well, if we draw that circle and if we draw a vertical line, it touches more than one point, so it fails the vertical line test. So let's actually answer the question here. Well, it says, Mia says that the circle graph is not a function. Okay, what Nora? Nora says that the graph is a function. So we know that Nora is not correct. So Nora, let's actually answer the question now. So Nora is not correct because the circle is not a function. Or let's just say because of the vertical line test. All right, because of the vertical line test. Okay, so we know that Nora, because of the, okay, so I don't know what pen is doing this, the vertical line test. Okay, so I know Nora is not correct. So now let's see if Maya is correct. So Maya, let's do it right here in red. So Maya says that the circle graph is not a function, which we already said that this is true. But why is she saying it's not a function? Because multiple value of x's map the same y values. Okay, so let's see if this is true. Let's just pick. Let's be more specific with our graph here. Let's actually give them some points here. All right. So let's see what happens when x is 2. When x is 2, you got y equals to 3 and y equals to negative 3. Is this exactly what Maya is saying? It's kind of like the opposite of what Maya is saying. Because in here it says that because multiple value of x's map the same y value. So what this is saying is that if I pick two x values, let's pick this one and this one, it will give me the same y points, which is not true. In here, let's say y it's 3, and in here y it's like 2. So this is not true. What Maya is saying is not true. It's actually the opposite. So here, Maya is correct. So she is correct, but she's not correct because of the. So here Maya is correct, but for the wrong reasons. Okay. No, what she would have had to say is that multiple y values are being given by the same x value, or so mine is correct, but for the wrong reason. What she should have said was that for any x value, for any, oops, what's wrong with this pen? For any x value, you have multiple y values. You have multiple y values. So what this is saying is that if I pick any x, I can see that there's two y values, one on the top and one on the bottom. It doesn't matter what you pick. What if I pick this x point? You have one value on the top, one value on the bottom. So for any x values, you have multiple y values. So this concludes this, I believe it's part 4. So this concludes part 4 of our Regents review for the Algebra 1, the one that was given in January 2017.